Okay, so these are the answers to test number 2. What do we got for A? Final answer is 2 to the power of 36. Oh, if anyone wants any explanations along the way, you let me know. B is x to the 8 times y to the 5, 2. That's a times down there. For C, after some flipping and simplifying, this is the good looking final answer. We got x to the power of 3, y to the power of 3 over 64. Those are 3's right there. For D, that works out to be 4 a squared b to the power of 6. E is a busy one with all those, quite a bit of flipping around and such there. But E gives a final answer of a to the power of 17 c to the 6 divided by b to the 7. And then F as a final answer is x to the power of 8 over y to the 12. So what I can do is I will take this away. Switch the screen now to the next page. Yeah, we got these to work on. Factoring type questions now. So for the first one, the answer works out to be x minus 5 times x minus 5, which is the same as x minus 5 squared. That's the good looking answer there with the squared up there with the exponent. For B, this works out to be 3x to the minus 2 times x minus 2. For C, this is x minus 2 and then x minus 4. D, p minus 6 and then a p plus 6 because it's a difference of squares. And then E, when we work it out, is GCF first, so it's going to be a 4 out in the front. And then a plus 2 all squared, so times by itself. And then F gets pretty busy. This ends up being 3x squared plus 4. And then times x minus 2 and then x plus 2. So going on now to, oh, someone's writing. I see it happening. This isn't the video, so you can check it out afterwards if you want. Yeah, okay. So that's, oh, I should put, this was number 2. The F one? Sure, I can do that here actually. Why is F the way that it is? Right, well, the question is looking like this. 3x to the 4 minus 48. So the first thing to do is a GCF all the time, right? So you do that. What's the GCF? The greatest common factor that can come out of both? 3, right? Ah, yeah. That's an 8, not a B. So 4 plus 8, if you're not sure, 4 plus 8 is 12. Does 12 divide by 3? No, so there's a little trick to see if something divides by 3. You add up the numbers and it gets a smaller number. And those numbers, they're more known, right? Okay, so 48, does it divide by 3? No idea. So I go 4 plus 8. I get 12. I get 12. So do you. Does 12 divide by 3? See? Yeah, good. So that means 48 divides by 3 as well. Okay, I can give you a number this long. If it adds up to a number that divides by 3, then a smaller number that divides by 3, then the big one divides by 3. And you can do it multiple times. 4 plus 8 is 12, right? And let's say we don't know. I forget. Well, what's 1 plus 2 from 12? 3. See? So 3 divides by 3. That means 12 divides by 3. That means 48 divides by 3. Okay, so GCF, we pull it out in front. We get x fourth minus, you do the dividing, you get 4, x to the 4, minus 16 there. Okay, and now from here, what you can recognize is that, yeah, it's a power of 4, but it's actually a difference of squares. This thing is like, it's like a squared minus b squared. Because 16 is 4 times 4. And then x to the power of 4 is like x2 to the power of 2 with a minus. So how does that work? One bracket gets a plus and the other bracket gets a minus, right? If it was just x squared, each bracket would get an x. But since it's x to the 4, each bracket gets a x squared. Okay, and then the square root of 16 is 4. So that goes there and that goes there. Okay, so normally it would be finished. But for this question now, there's more to do because look what we got. 3 is finished. X squared plus 4 is finished. But whenever you have squared things and a minus, you can keep going. So this last bracket, we can do the same thing with. 3 stays because it's a plus with squared things, it stays. But this last bracket can switch up. We can factor it. How does it factor? Plus over here, minus there. X and an X to give x squared. What's the square root of 4? 2. So it goes there and it goes there. Finished. Okay, so that's how to do question F there. Can I switch? Okay. So going on to number 3, that's some multiplying now. Product, multiply them out. So for A part, that works out to be 10x squared minus 41x plus 21. For B part, when you work it out, it's x squared minus 25. And then for C parts, when you multiply it all out, oh yeah, for C part, what I'll do is, this is the answer. Like that. And the trick for C is to think about 3x minus 2 squared. That means, and this is the very good idea to do, go 3x minus 2 times 3x minus 2. Write it out side by side like that. Because there's two of them multiplied together. One goes there and one goes there. And then you can do the rainbow. You know? And then you'll get all the terms for that. Okay, so that's C part there. 4 part is part 4 rather. Oh, whoops. And even 3 isn't on the screen. What the heck? What kind of teaching is this? So those are the answers to 3. Now here are the questions. I got them on my page here, but no help if you can't see them. There we go. Make it fit, make it look good. Okay, so those are the questions for 3, and those are the answers there. Question number 4. It says evaluate with all those minuses in there and such. So the key thing for this type of question, without a word of a lie, is to write it big. Because those little exponents can start getting scrunched together and then mistakes are made. So I'm going to use the whole page for this one little question. And hopefully things won't get scrunchy. What do we got? 4x y squared on the inside, squared on the outside. On the bottom, oh, we got negatives and negatives and negatives. Oh man, this is going to be, got to be super careful here. Not just copying the question out, but oh, you see, look at that. It's a -2 actually. There we go, -2. And then a -1 on the outside. And as it shows, we're going to let x equal -2 and y equal 3 when we work this out. Okay, so you could put the numbers in right away if you're careful with your brackets and such. Or you could simplify this with some algebra first and then put the numbers in afterwards. Okay. What I think I'll do for this, I'll do the algebra first because it'll remind you about what some of those square root laws are, or exponent laws are. Okay, so this 2 upstairs on the outside goes into each thing on the inside. So we'll get a 16. We'll get an x squared. And then we'll get a y to the power of 4. This 2 on the outside is, be careful. It's on the outside. And what I'm going to do then is put, I'll deal with this -2. So watch. 50. Y will go downstairs like this. And that minus with the 2 is gone. And we still have the -1 on the outside like that. We can see, so this minus is gone now with the 2. It's downstairs. We can get rid of this minus by switching. Inside the brackets. So it's going to stay as 16x squared y to the 4, all divided by 2. And then switching these, the y2 goes to the top and the x goes on the bottom like that. Simplify a little bit. 16 divided by 2. No. I'll take 8. Yeah. So 8 there for the 16 divided by 2. On the top is still x squared, then y to the 4. Now, this bottom thing, watch, this means this top part is dividing now by y squared over x. So we can rewrite it as 8 times x squared times y to the 4 times now this upside down. Okay, so the dividing is gone, the fraction is gone, the big fraction is gone, and this is flipped upside down. The dividing is now times there, and this is flipped upside down. Maybe it's easy to put the numbers in first next time. Okay, but here on in though, 8x cubed, because we got 1x times those 2 x's that are there, that x squared. And we got y4 over y2, which is y squared like that. At long last, the question says, let x equal -2, which, yeah, maybe should have done in the beginning. Making this solution harder than the hard version. And you can try the easy version on your own. And of course, you should get the same answer. That's a 3 in there for sure, and that's a squared for the y, so that's a squared there as well. All right. So I guess the thing to watch is that 8 stays there. When you do your calculating, that second answer will be as a -8, and that will be as a 9. And this will give your whole final answer of being something like -576 when you work that out. Yeah. Okay. On to the next one. There's a number 5 that you see just on the screen. We'll move it up so you can see it. Yeah, find the perimeter of this thing. Okay, find the perimeter below. Looks like the question's cut off on the camera, or on the screen, but it's all there. Okay, so the perimeter, as a reminder, is all the way around. That is the distance perimeter, the distance around. So if I start on the lower left, If I start down here, I'm going to go up by 5 to get to the top on that side. I'm going to go over 6 on that side. I'm going to go down by 2 on that side. Now, this side is missing. Missing. How far does this side here have to be? Yeah, how long is this part? It's going to be 3, right? And how do you know? Not bad. Half the value there. Yeah, careful. You can't always trust the pictures, especially this one, the way it's turning out. So, but take a look though. What's the distance down here at the bottom? See? Yeah, exactly. So if the whole thing is 6, this part is given as 3, then this new part has to be 3 as well. Yeah, for sure. Same thoughts here. No number, but it's 5 going from the top all the way down to the bottom. This part is 2. So how long does this section have to be? 3. And so then going all the way around, you add up all these pieces together, right? So starting there means we go 5, and then we go a 6, and then a 2, then a 3, just going around. 5, and then a 6, and then a 2, then a 3. We're right there. One more 3, and then one last 3 to get back to where we started. Notice I circled it so that we didn't go around too far, right? Okay, so you add these up, and this will give what the perimeter is going to be. The distance, oh, with an I in there, the distance all the way around. So 5 plus 6 plus 5 plus 6. Okay, so what are we looking at here? Good, 22. And include FT for feet because they are given in this particular question. Okay, so that takes care of that one. Next question, number 6. All right, like that. So we're finding the shaded area, okay, of the square. So interestingly, it's a square. What does that mean about the sides? Yeah, the sides are equal. So we're going to use that when we do the answer. So it's going to get covered over by this here, right? All right, so our picture's like this. What number is this? 6? Number 6 for our square. Equal sides, as you said. So it's given as 12 there, but we can write it as 12 there. And so that means the full area is going to be length times width. The area is going to be 12 times 12, or 12 squared, which I saw. That was nice to see. And so therefore we get an area equal to 144. Okay, now on the inside, there's this circle. And I guess the thing to notice is that the circle touches the edges of the square that is there. So that means the distance all the way across, it's going to be the same as a side. So that's going to be 12. And then importantly, the radius, the distance from the middle to the outside, is half of that. Okay, so the radius then, r, is going to be 6. Okay, so now then, thinking about the circle, the area of a circle is pi times r squared. And some people use 22/7, some use 3.14, some use the calculator and the whole thing is in there, or a lot of it is in there. Okay, so you do that. And or some people just leave it. That's what I did actually. I put r in there. So we get pi times 6 squared, which is just 36 pi. And that was good enough. Now to get the part that's left over, the shaded part, what do you do with these areas that we just found? Well, you can take the area of the square, subtract away the area of the circle, and that gives the area of the shaded bits, the leftover parts. So it'd be calculator time or fingers and toes time. Area of the square minus the area of the circle gives you the area of the shaded part that's left over. And I do the number crunching and I just write it with 3 numbers there, 30.9, and it ends up being meters squared as the final answer for that one. Oh, 12 altogether would be the perimeter of the square only. That'd be walking, starting here, just like our earlier question. Starting here, 12, 12, 12, 12, plus, 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 48. That's the perimeter. Yeah. No, they want the leftover bits. You have a square, you cut a circle out. What are you left with? Right? That much. Okay, now it's question 7. Line time. Got a few of these, eh? Okay. There's a little bit more to question B for this one. Okay, lots more. Question B, we'll get there. Question 1 first, or question A. Since we got those 2 points, we can just find the slope using the slope formula. Maybe that. Class, can you see that okay? Still all right? Okay. All right, so looking at, after all this adjusting, looking at the first one there, 7A. That's just going to be the formula, slope formula for that one. Y2 minus Y1 over x2 minus x1. And the answer you get for this will be that the slope is 3/4 when you work it out eventually. For question B, the next one, it's talking about perpendicular now. The points that they had, -2 and -2 and -4, 7 and -1. All right, so we can just use the slope formula for this one. Use a slope formula again. So we get the slope from these lines. That's going to be 1/3 when you work it out and reduce it. But then since we want, the question says, find the perpendicular slope, you got to flip it upside down and change the sign. So flipping this upside down turns it into a 3. And since it's positive, the perpendicular slope is now negative. For question C, being careful to have everything there, the final answer is x is -2/3. And then lastly, D is pretty nice. And I think it might even be something like it on the exam. All right, what's happening with those numbers there? Well, the slope is equal to 3. That's the I part. The I is equal to the y-intercept. So that's -7. And then the last part, you just plug it in. That is, plug 12 in for x and work it out. And you get y is equal to 29. All right, question 8 is kind of on there. For question 8a, the x-intercept is at 8/3, and the y, which means you'll have the coordinates 8/3 and 0. And then for the y value, it's -2, which means it'll have the coordinates 0 and -2. For B part, it says the slope intercept form. So that's just going to look like this. Slope along with the intercept form there. It's off the screen, but it's on your page that you have. C part. A lot of people did this well. Okay, with the points that are given, it ends up looking like that. Remember, the signs are opposite. It's +1 in the coordinates, so it's -1 in here. +5 for the coordinates, so -5 there. And then for D part, it says leave it in slope point form. You do the work, you'll get the slope is equal to 3/4. And so that means the answer, if you leave it, it's going to have that -0 in there. But if you take it further, that 0 will go away and be some slightly other version, but that should be okay for the slope point form. Ooh, heavens, still more to do. Question 9 of like 2000. So I'm going to, I think, give the video a pause. And we'll rejoin later on. Pause that. Okay, question number 9. It's just on the screen there. The equation, that is. And so because of this style, I would find the x and y intercepts first. So I would let x equal 0. And therefore you get the y-intercept. And so it's 5 times 0 minus 3 times y is 15. So the y-intercept will end up being minus 5. And so we get 0 and minus 5 for 1 point that we can use to graph this line. To get a second point, and again, because this is in standard form out there, let y equal 0. So therefore, you get the x-intercept. And so that leaves 5x minus 3 times 0 is 15. 5x is 15, meaning x is equal to 5, which would be a lie. X is equal to 3. It's better. And so you get a second point of 3 and 0. So to put this professionally onto a graph, right? Ruler for sure. Look at that. So good looking. All right. 0 and minus 5. So this is for the y-intercept. So going down by 1, 2, 3, 4, and then big 5 right there. X-intercept, 3 in the positive direction. Boom, right there. So with those two dots in place, there we go. Created the graph. Done and dusted. You forgot? Okay, it'll come back. Okay, so that's for lucky number. Does that have to do with this one? Have to do with the next one? Okay. Okay, in just a second. You have to get these buttons. Yeah, pause this video and then okay, so for this number 10, we're going to find the slope of that line, the blue one, A there. So we can do it one of two ways. One is to just find 2 points and then use the slope formula for it. And the other way is to find a point and keep track of how far you go. Yeah, that's okay. How far you go to the right and how far you go up. There you go. Slope formula. Or choose a point and then you see how far you go to the right and how far you go up. And that can get you the slope as well. So for A, the answer ends up being, for A, the answer at 10, that is. The answer ends up being 2. And then for B, slope ends up being -1/2. And then for C, are these lines perpendicular? And the answer is yes, they are perpendicular. Because for lines to be perpendicular, the slope, you turn it upside down, and then you switch the sign. And look at that. We got a 2 to start with, and then it switches to a minus a half. So that means, yeah, the lines are perpendicular to one another. Okay, and that's what you need for number 10. For C, yeah, exactly. So yes, they are, and why? Because if you start with 2, turn it upside down, there's reciprocal, and switch the sign, then you get that other angle, the other slope. Okay, so yes, they are perpendicular to one another. Let's back to some. What we got here for number 11. Yeah. Okay, so that's good there. So for number 11, the slope from the first line is equal to 4/3. And then the slope from the other line, well, I don't know what it is. We got to work it out. See, I know this one right away because it's set up as y is equal to mx plus b. Just read it off. Oh, there it is. Just like that. But for this next one, I'm going to solve for y. I'm going to switch it to the slope intercept form like that. So the 4x is going to go over, which means it's switches sign, minus 4x. Then I'm going to divide everything by 3, everything. So divide, actually I'll show it first. Show it, then you do it. Divide that by 3, that by 3, and that by 3. So you get y, they cancel out. That's why we do it. Minus 4/3x plus 1. Okay, so this question is about lines being perpendicular and parallel. If the lines are parallel, the slopes are the same. So we got 4/3 from this line, and we got minus 4/3 from that line. So are they the same? No. Parallel? No. Perpendicular? Not going to write it out. Going to be clever. You switch the signs, that's part of it. And so, yeah, one's a plus and one's a minus. That part's okay. But you also have to turn this other one upside down. Okay, that's not upside down. Okay, so not perpendicular either then. So that means the answer is neither. They're just two regular lines going out into space, and eventually they will cross. We could figure out where if we graph them, but for this question, not parallel, not perpendicular, neither of them. For lucky 12 there, the graph is just off behind my screen there, behind the camera. So what I'll leave you to do is to check. You find a couple of points, nice, easy ones to read. And you'll see that the slope is equal to a minus 1/2. To get the slope point form, again, choose two nice, easy points to read. I see something like that, y minus 1. Use the same slope. And then when y is 1, x is equal to 2. So x minus 2 like that. Slope point form when it's written like this. Slope intercept. You get y equals mx plus b. Fill in the number for m and fill in the number for b. So it's still minus 1/2. Slope doesn't change, the line doesn't change even though we're changing the style. And then from the graph, it's hidden, but you can clearly see that the graph crosses the y-axis at 0, 2. So it crosses the y-axis when y is equal to +2. Which takes us to 13 and solving systems now. So put those up. Make this a little smaller. Yeah, this was a weird number, unfortunately. Oh, there's the graph that was hidden, showing it anyways. It's kind of silly. Okay. There you go. Y-intercept of 2 for that earlier question. It's getting pretty small. Oh, now it's invisible. Here. Oh, brother. Here in the class. So I'm going to copy the system down on the camera, make it a little bit bigger, and then work it out. So this is going to be with substitution. I'll put substitution, apostrophe N. Yeah, weird numbers. I don't know who made this question, but oh, even weirder if you copy it down wrong. So that's a -5/2, x minus 3. And then the other equation is standard form -2x plus 5y is equal to 10. Hey. Yeah, importantly, it says show your answer as a coordinate, x, y. Okay, so let's make sure that happens. But with substitution, how does it work? Substitution means replace. So you replace y with stuff, y with the x stuff that's there. So I'm going to replace this y with all of that x stuff that's there. And the equation is going to look like this. -2x plus 5 minus 5/2x minus 3 equals to 10. Now let's just check. -2x, yes, plus 5. And then no weird copy errors, right? Y goes in for that. That looks good. So I've seen people work on these two numbers. It's not how it works. You got to do the multiplying first. So that means we're going to do this first, just like that. So get -2x minus 25/2x minus 15 is equal to 10. Working on these x's, this is -12.5. And at the same time, I'll move this to the other side and switch the sign. So this gives yeah, it's weird. -14.5 for some reason is 25. And you work this out. And with my mathematical brain and one part and my eyes to the answer key on the other, let's see that x is equal to -1.72 and a bunch of change there. 4. 2, 4. Okay, yeah, it could be. Okay, so that's part of it now. Remember, we got to write our final answer as a coordinate because it's all about where these lines, these are lines, all about where these lines cross. That's the x values. Got to figure out the y value now. Where does that go? Well, to figure it out, we'll put it into the first equation because the answer we get will be y equals. So you put it into there. I'll show how it looks. All right. You get y is equal to minus 5 over 2, our new x, or the x that we just found, minus 3. And you get a y value about 1.31. And I say about because of rounding and stuff like that. Final answer, as a coordinate, as a location where two lines cross, right there. Weird answer, yeah. Yeah. Real life answer. Okay, that was 13. Number 14 is elimination. Number 14 is off the screen is what that is. Okay, so just solving the system again. That's no mystery there. Number 14. I was just thinking this video is going to take 3 hours to load up. It's okay. Good quality education. Or at least the answers are there. This is the system elimination. What has to happen? Numbers got to match. So you get a 3x minus y is equal to 5. And we got a 5x plus 2y is equal to 12. So do these x's match? No. Those y's match? No. These ones, don't worry about. So we got to get something matching. So which one do you want to work on? Get the y's to match. Sure, that's smart. Okay, so we'll get the y's to match by working on this equation here. What are we going to do? Multiply by 2 indeed. So 2 times 3, 6. 2 times minus 1, minus 2. 2 times 5, 10. And then here, no change. We'll just keep it as 5x because now we got a match. We got a 2y upstairs and a 2y there. And because of an important conversation yesterday, these signs are opposite from one another. That's also important. So with those being different now, we eliminate them by adding together. Minus 2y plus 2y gives 0y officially. We're adding. So 10 added to 12, 22. We're adding. So 6x added to 5x, 11x. Plus 0 like that. So 11x, clean it up, is equal to 22. X is equal to 2. As usual, what is y equal to? Or the other coordinate? We found x in this case, so what is the y? Well, these are our two equations. Neither of them super nice for the y, but I think the first one's probably the nicer one of the two. Okay, so I'm just going to use the first equation there. 3x minus y is equal to 5. The x we just found is equal to 2. So that's a 6. I want y to be positive, so I'm going to move it to the other side. That means we're going to move the 5 over to the left, and it'll be negative. So some pretty fast switch in there. Notice 5 is positive, it switches over because it's negative. Y is negative, switches over positive. So y is equal to 1, even though it's on the right-hand side. Good looking final answer as a coordinate is 2 for the x, 1 for the y. That will be the point of intersection for for the lines in question number 14, which, yes, are visible on the screen there. Okay, so this is our original system. Numbers don't match. Make them match by multiplying. Now we work this new system out. Add everything up, get one of the x's, get the x, substitute to find the y. Good times. Well, let's do 15 first. Yeah. 15. Oh, yeah, 15. Weird numbers. So again, the question's a bit long. I'm just gonna transfer it to the page and then work it out. So number 15. What does it say? First term is 11. So I know it's going to look like that. We'll see if you do. 10th term is 70. And for A part, it's what is the value of D? And then sum of the first 12. Yeah, I should be able to see that. Okay. So first term's like that. 10th term is that. Got to find what D is. Well, I happen to remember, and hopefully you do too. And then with an arithmetic sequence, we can write it like this. And so we get 11 there, plus hidden in here, n is equal to 10, right? N is equal to 10. So that means we get a 10 minus 1 is equal to D. A10 is there. So we get 11 plus 9D, 9D if you say it fast. And then A10, the 10th term is 70. A little bit of algebra. I want D by itself. The 11 will go over. That creates 59 on the left side, a weird, awkward number, but divide both sides by 9. Divide, since it's multiplied, do the opposite. And so we get 59 over 9 for the D value that is there. That's a 9, not a 4. 59 divided by 9. And now we're probably going to have to use that for the, yeah, I'll have to use that for the next part. B part now. Let's find the sum of the first 12 terms. Okay, let's see what it's going to be. The sum of the first 12 terms. Well, there's two different formulas. One of them has the last term and one of them has the, well, doesn't have the last term. So the one that doesn't have the last term looks like this. And I'm using this one because if you look at the original question, we're not given what the last term is. We're given the 10th, but not the 12th. We could find it and then we could use the other formula. It's not so tough, but I'm just going to use this one directly. Sum of the first 12 terms. Okay. Oh yeah, officially, this is n at this point. The question is, what's the sum of the first 12 terms? So that means n is equal to 12. That means in the next line, we're allowed to update whatever n is. And not just in this one location, but everywhere along the way. So we get S12 is 12 over 2. So there's an n in there, and that one there as well. So 12 terms is what we're looking at. D we have, I was just about to write D, but from question 1, we got it as, or question A, 59 over 9. Awkward fraction, but hey, that's the life we're in. Okay, keep it neat. You're going to have triple stack and fractions and quintuple brackets in there, so don't let it get scrunchy. Sum of the first 12 is 6. Oh, do we have the first term? Yeah, that's still on the screen. First term is 11. So we can use that. You could even put that at that step. Okay, so 2 times the first term, which is 11, plus, simplifying this, 11 times 59 over 9. Okay, so 6 now, this will be, that's 22. Plus 11 times 59 all over 9. And you do all this good work in your, off to the side if you want, calculator. You get something that looks like 564.67. 564 and 2/3. Okay, that's some form of that for this question 15, part B. Okay, so we had to find the sum. Didn't have the last term, so we use this version of the formula. We're looking for 12 terms, so n is equal to 12. The first 12 terms, that is. So n is equal to 12. So we got 12 there for all the n's. D from before, and then A1, the first term from before as well. Notice these two, there's two 11s, but they're not the same. This comes from n-1, and this comes from the first term. It's a coincidence. Final answer, as it shows. 564 and some change there. Okay, beauty. Last question. Number 16. Covered up, but not impossible. 5, 9, 13. Okay. What do we do with them? What's the question? The sum? It goes on forever. Sum, the answer is infinity. Sum of the first, the first 12 again. S12 is equal to what? And yeah, that's just off the screen, right? 5, 9, 13, sum of the first 12 terms. Okay. So let's make a list of values that we have that will help. A1's 5, yeah. N is equal to? Yep. Yeah, we can find D for sure. What's D equal to? 4 for sure. You take a number, subtract the number in front of it. And so D will be equal to 4. Yeah. That's it, eh? Okay. That's what we got. So then do we have the last term? No. Okay, so we end up using the same style formula as the earlier question, number 15. 2 times A1 plus n minus 1 times D. Going through our list, n is 12. Make sure you put 12 in there and not 6. Like you might see it. No, I didn't. It's a lie. I didn't, but you might be tempted. Oh, I see it's 6, and you put a 6 in there, and then you'll end up getting a 3 in the next. It'd be wrong. Okay, so be careful. 12 goes in for n. What goes in for A1? 5. What goes in for n? Still 12. And D, way nicer than the other question. Not 59 over 9, 4. Yeah, so that's good. This isn't a decimal, this means times. Yeah, but this should be good. 2 times 5, 10. What's this? Yeah, 11 times 4. So, yeah. And so more for interest, you could do the rainbow here if you want and then add up those results, right? But it gets a bit awkward. So yeah, do it in the regular way. Add up the brackets first. 54. That's pretty nice. 6 times 5 is 30. It's 50, so it's 300. And then a 24. So a mini rainbow in a way. And then you get final answer. Yeah, include that S12 there for professionals, for professionalism. S12 is 324, finishing off the solutions for this test. Message out with any questions, and keep in mind you can always stop and rewind the video quite easily in order to review a section. Okay, message out with any questions. Ciao.
You